I haven't. I got to talk. I'm going to go ask before we're done here with this class. I keep forgetting. I wasn't here yesterday, so. All right. Okay. All right. So let's do a few notes here. This would be probably my last day of doing the trig functions. If you guys feel comfortable with it, we have a Google question of the day today. That's it. And then tomorrow we're going to be moving on to section 4.4, which is graphing, which is way different than what we're doing here. So, and it will explain some of the values and stuff. You will probably not need a calculator tomorrow. I'll just kind of warn you of that. You'll just need a lot of paper. So when we take notes tomorrow. So and that's the last couple sections. We have section 4.4 and 4.5, which I mixed together, which is the last sections of chapter 4. Then we'll probably take a quiz sometime next week, and then we'll move into chapter 5, and then we'll take a big chapter test at the end over chapter 4 and 5 because they still based on trig functions. So it's not like we're moving on to something different. Okay. All right. Let's do a couple notes here. The big thing what we've been dealing with is the trig functions for acute angles, you know, how to find it for like for those weird random right triangles. I just threw some numbers and you had to use the trig functions to solve for a missing wall. You still got to know that stuff. It's still a big part of what the trig functions are used for. What we're going into now is the obtuse angles. I started this on Tuesday this past week. Yesterday, Mr. Greiman should have put a few notes on the board with this stuff. You were given a couple questions at the end of class where you could just try some out. He has pretty good knowledge of the trig functions just because he's taught for so many years in physics and stuff. So he probably knows it probably better than I do in certain cases. So, but just because of what he's used it for. So, but anyway, kind of going through this stuff. What I want to talk about today. What I want to discuss today is the positive negative sign chart, which is this chart, right? You know, where the trig functions are positive and negative, so that you know before you even start a question, like, ooh, my answer is going to be negative. I don't even have to worry about it. This is a chart you need to have somewhere in your notes, if you haven't already. Then we're going to talk about how to do just random trig functions, and I'll just kind of pick some random numbers here for you. So, are we ready to go here? Okay, all right. So let's do a quick example here. What I'm talking about today. So let's say that I was gonna do the the tangent of a 330 degree angle. Let's say that that's what my question is, and it wants to know the exact answer for the tangent of 330. This is my example here. Well, where does 330 land? Fourth quadrant. So if you don't remember that, 0 degrees is right here. Now I'll erase all these marks here in a second. 0 degrees is right there. That's 0 degrees. And what you do is you spin around counterclockwise until you get to the angle that we need, which is 330. So it ends up in the fourth. Okay? So by just knowing that fact that I'm landing in the fourth quadrant, will tangent be positive or negative there?
Negative.
Negative, because the two trig functions, the only two that will end up being positive in the fourth quadrant is cosine and secant. Those are the only two that will end up being positive. I'll talk about why that works today. That's something I think I had in the notes yesterday that Mr. Greiman should have showed you, like the reason behind like why it's positive or negative, and why certain trig functions, but you probably didn't get the in-depth version of it. You probably just got the real quick, here's why. The goal here today is not to just figure out if it's positive or negative, which we figured out it's negative, right? Tangent's negative in the fourth. It's to know the exact answer. Exact, not decimal, not this. We shouldn't need this. You should be able to just use your special triangles to figure out what the value is. So it uses the special triangles, the 30, 60, 90 triangle or the 45, 45, 90 triangle, and you set it up, and then you just do the trig function that it provides you in using a reference angle. I'll explain that concept here in a minute, and that gives you the exact answer. Okay? All right, questions with what we're doing?
No.
Okay, so let me get rid of some of these marks here. All right, so let's get rid of I'll just erase this. All right, so we're still going to do the tangent of 330. I'm not going to get rid of that. We're still going to answer that. I just want to go to the next slide to do that. So, all right, so for the tangent, whoa, what did I just click? All right, the tangent of 330. So we understood that it was going to end up in that fourth quadrant, kind of going this direction. Here is my angle for 330. Okay, and this, again, what you're looking at here, this was the x-axis, this was the y-axis, just so you're kind of aware of what you're actually looking at. In fact, I'll put that in black. So x-axis and y-axis. Okay, so we're ending up in that fourth quadrant. Now, what you do is you use a reference angle. A reference angle always goes back to the x-axis, never the y-axis. It's always the x-axis, just so you're aware of that. So we're going to bring this triangle straight down towards the x-axis so it makes a right triangle. So whatever quadrant you're in, bring it back to the x-axis to make your right triangle.
Why can't you go to the line?
Because that's not how the trig functions are based on. It's based on circular motion, which what's the best way I can put it? The coordinates and how you fall will always have the x number first and the y number second, and the reason why you bring it back to the x-axis is so that this value is always the x, so it's the x number. You don't bring it back to the y number because you have to look at the distance from the center going x-wise first. That's why I always go to the x. So if I'm like over here, you have to, instead of going like this direction, I go this way because the first number I need to look at is the x number, not the y number. By you bringing it across, you'd be looking at the y number first, which is not a number we need. I know it seems weird. It does make a difference when you actually look at how the triangle's set up. Because, depending on how far this is tilted, do you see that the difference is here make a big difference in terms of like y's and x's, in terms like they'll be different numbers in terms of angle. So that's I know it's super hard to explain that.
But that's still x. So.
Yeah, I understand that's still x, but look at the angle that you're at. Look at the angle, like this angle right here, because this would be inside your right triangle versus this large angle. Do you see that?
But that's the same angle as that one.
The idea is that this would be the opposite wall for it. And this would be the angle you're using. You always have to be along the x-axis because the adjacent would be different here. That would be a different number in terms of adjacent. And it's super hard to explain that to make sure that it makes sense. I'll come back to it. Come back. Hopefully I'll have a better way to explain to you. Okay. All right. Okay. Let's keep going here just so we can finish this up. All right. So. Okay, so the first number here, if we're doing the 330, we have to bring it back to the x-axis and you subtract it from the x number. So if I take 330 and I subtract the x value for what the angle is, if I went all the way around a circle, this would be 360 degrees. So bring it back to the x-axis, I subtract the 330 from it, and this makes a 30-degree angle. So it's a 30, 60, 90 triangle. So by seeing that reference angle, the reference angle is this angle right here. It's referring back to the x-axis. This is the number I needed. Does that make sense, what I looked at there?
Yes. Mm-hmm.
You always bring it back to the x-axis. So if you're on the other side, like what I was kind of trying to show Evan here, when you're bringing back the x-axis on that side, you're using 180 because that's the x-axis on the other side. It's 180. So now I'm using the 30. So when I set up my special triangle here, you have to use the walls for the 30. So the wall opposite of 30 is always 1. The side opposite of 60 is always the square root of 3, and the side opposite of 90 is always 2. That's how I always identify where the walls go. Now, to explain further, some of these numbers are positive and negative. Some of them are. So when you're thinking about the normal quadrant system, all right, you're on 0, 0 here, right? So here's 0, 0, it's right in the middle. If I went this direction, what type of number do I have?
Positive.
Positive, right? The x-axis goes positive to the right. If I went down, what type of numbers do I have?
Negative.
Negative, so the 1 is negative. Think about it just common sense in terms of distances. Okay, so this would be a -1, the 3 would be, the root 3 is positive, and then the diagonal, the hypotenuse, is always positive. How that works is because of the Pythagorean theorem. You have to square numbers so it turns them positive anyway. So when you do the Pythagorean theorem, so that will always end up being positive. So you don't have to worry about a negative sign on the diagonal. Now, doing the tangent. So now what we're doing is this number up here, is right, we're doing the tangent of 330. That's the whole goal, is to find the exact answer of this. Well, that's the same thing as the tangent of 30 degrees in the fourth quadrant. So it won't, so if you use your calculator, don't type in tangent of 30, don't type that because it will give you a positive number. But we're in the fourth quadrant, so setting up my triangle here, I can now tell you what my answer is going to be. So tangent, if you don't remember, it stands for opposite over adjacent. Now my reference angle is the 30. So what is the opposite of 30?
-1.
-1. The opposite, or sorry, the adjacent to 30. Square root of 3. And that's your answer. This is the exact answer.
That's it?
That's it. Done. Complete. Move on to the next one.
Beautiful.
Okay. Now, if you want to see it on a calculator, I want to show you the numbers, what we're getting here. But again, by setting up your 30, 60, 90 triangle in whatever quadrant you need and getting your reference angles, it will always give you the right answers every single time because of where the adjacent and the opposite wall falls to your reference angle. That's just how it's always set up. Now, I'm going to show you that you do get the right numbers, that the fourth quadrant would give you a negative versus a positive, just so you're aware of that. Again, if you were to type this in your calculator, it would give you a positive number. So make sure that you understand you're in the fourth, and that's why this ends up being a negative, because of that. The 30 just helps you with how to set up your triangle. So, all right, questions on the setup though on this one? Okay, let's type this in a calculator just so you can see this. Okay, so typing these numbers in. All right, so tangent of 330, so it should be negative. So there's my number. I didn't close the parenthesis, but there's my number I'm getting. If I typed in the tangent of 30, this should be the same because it's a reference angle. It should give you the same number. It just wouldn't be negative, right? It should be the same answer. So that it gives you the same number, the same fraction. It didn't understand, like typing in 30, it didn't realize you're in the fourth quadrant, so it didn't know to put a negative sign on it. Now, that's the same thing as 1 divided by the square root of 3, right? That was what we were just doing. If you put a negative sign out front, and that's the same number. So I just want to show you that that's what it's actually doing behind the scenes. So the weird thing is, like, I had a question the other day, is like, how does your calculator know like these weird decimals? Like, because obviously it's pre-programmed, right? There's memory in there. There's a certain amount of RAM. That it's pulling up like certain values. It has the basic 30, 60, 90 triangle programmed in. So it knows what numbers to type and how to enter that in. And when you type in other angles, let's say like if you typed in like tangent of 70 degrees or 35 degrees or weird numbers, 15 degrees, it's using these special triangles, the 30, 60, and the 45, 45, 90 triangle, to actually give you answers. And it's doing the stuff we're going to do in the next chapter. Like, how do we come up with weird numbers without this thing? Like tangent of 15. How do we find that number? Because we don't have a triangle that has 15 in it. And it's not just taking this number and cutting it in half. That's not what you do. Like, how does it know? And that's what we're going to be looking at in the next unit. It's like there's formulas that will explain and it really comes down to, do you understand the trig functions and do you know what they're equal to? Okay, so I'm going to give you a kind of a handout today as you guys are kind of sitting here to show you what we're going into the next unit, the next chapter, I should say, not the next unit. We're going to be moving to chapter 5 in the next one, which is still a part of this stuff we're learning. Okay, questions on this though? Let's do one more, and then I'll be done for the day. One more. So let's do kind of a big one. Let's go with the sine of, I don't know. Let's go sine of 480. Sine of 480 degrees. I don't know if we did this one yesterday. I hope I didn't. So I don't remember what problems I typed for you guys yesterday. I don't think I did. I got the notes in front of me. I can go looking back and see what I gave you on the notes for Mr. Grammer. No, I didn't. Good. Okay. All right. So let's talk about this number. So what I need to do first is to figure out what quadrant I land in. Okay. So 480. Do we agree that's more than one time around?
Yes.
Okay. So in terms of just like figuring out what quadrant I'm landing in, I went all the way around and probably something extra. Now what I'm going to do is I'm going to take 480 and subtract 360. So 480 minus 360, that means I went a full circle plus 120 degrees. So that means I went and I'm landing, like, and I already heard it, I'm landing in the second quadrant. This is where I'm going to land. Okay? So I'm landing in the second quadrant by 120 degrees. Full circle plus 120 degrees makes 480. Okay, does that make sense? Now, what we're going to do here is we're going to be we're in the second quadrant at 120 degrees, right? So here's my 120 degrees over here. So my reference angle, I have to always bring it back to the x-axis so that your angle is always at the origin. So it's along the origin, and it has the correct sides, I shouldn't say the right, but the correct sides for the adjacent and the opposite walls, because the numbers could be different in terms of value. So in this case, my reference angle ends up being 60 degrees. Now, if you don't know how I did that, I took 120 and I subtracted it from 180. Since I land in the second quadrant, you're bringing it back to the x-axis, which this angle over here is 180 on the. If I went to the third quadrant, it'd be 360, right? So, or the fourth quadrant, I should say. So on the other side of the x-axis is 360 on the other side. So I always bring that back, so that's why I'm ending up with a 60-degree angle, and that's my reference angle. So it's a 30, 60, 90 triangle again. The side opposite of 60 is? What is square root of 3. The side opposite of 90? 2. And the side opposite of 30 is 1. And now, in terms of numbers, since we're in the second quadrant, I have to think about my negative signs. If I go to the left on the x-axis, I'd hit negative numbers, right? If I go from starting at the origin, if I go to the left, I hit negatives. If I go up, I hit positives. And your diagonal is always positive, right? The diagonal of the hypotenuse is always positive. Because in the Pythagorean theorem, you have to square numbers, so it turns positive. And so in terms of numbers wise, now what we're doing is we're looking at the sign now, not tangent. We're doing sine, so I have to think about what sine stands for. So again, this is going to be the same value as the sine of 60. That's my reference angle I'm using, which sine stands for opposite over hypotenuse. So what is the opposite of 60? Square root of 3. The hypotenuse to 60? 2. And there's my answer. This should be the number that it gives you, and I think it's like 0.877 something. So square root of 3, let's see, square root of 3 divided by 2, 0.866, so it's 0.87 roughly. So approximately 0.866. All right, questions. Okay, your Google question of the day today is one of these, where I just give you a trig function. I want you to see if you can set up your right triangle in whatever quadrant it lands. Tell me the exact answer. Tell me, this square root over this number, or negative this number over this number, and just tell me the fraction. You don't need to tell me the decimal. Tell me the fraction you're getting. Okay, I'm going to give you some property sheets. So this is something that I know this is going to be a little blurry. Apologies. It's the same same property sheet I hand out every year. So.
Self-defense. He was sexually harassing me first. How do you type this?